How are you doing today? So today, part of this video, we will try to understand what are different dictionary tables that are available in Oracle database and how to query and how to remember the pattern of the tables, right? So what are dictionary tables in short? Let's say that we are trying to create a table or we have created a table and that has been stored, but we don't know where it was stored and what columns the table has, what was the data type or the data size that has been defined for different columns in the table, then we will have to check with the metadata tables, which are nothing but called as dictionary tables. So, be it like we create a table, we create a constraint, we create an index, and we create a view, or we grant the permissions on top of a table to a user who granted it, and all such kind of information can always be checked in the dictionary tables. So let's try to query as many tables as possible and try to find out useful columns which are important for our daily life as we keep working on the database projects, right? So the very first thing and the foremost thing is, how do I check what are different users that are created in a database? It is often a question when it comes to data warehousing, especially that we want to get the data from a table, but we don't know whether the table exists. Even if the table exists, in what schema it exists, we don't know. Or should we create new schema before creating the table? We don't know. So in that case, how do we check what are different users that are available? So one way of checking it is select star from all underscore users. So one thing, if you notice here, it is I'm calling it as all underscore users, and if I just run it, we can see here all the usernames. So these are different users that have been created, and here is the unique ID that is assigned for each and every user that is created. And yeah, and these are some frequently used columns, even not even user ID that is not widely used, just username. So along with this all underscore users, we also have something called db underscore users. And here, if we look at, we have slightly more information than all underscore users. So like if you look at username and user ID, both of these are same. And then we have something called account status, which tells us whether this account is logged or not. Let's say that you want to find out whether your account is logged. In that case, you can just do select star from our good users, and you can look at the account status. If it is logged, that means that you'll not be able to log in even if you provide the password. If it is open, then only you'll be able to log in, right? And when something was logged, you will also get to know the date when it was logged. And if you look at here, for access dollar null, it says that it expired and logged. That means that this particular account password has expired. It's not that the account has expired, but its password has expired, and we will have to reset the password and then unlock the account. Then we'll be able to use it. So for example, alter anonymous. So as we can see here, there is a user called anonymous which says expired and logged. What I can do is identified by tiger account unlock. So this is a command I can run which will reset the password and then it will also unlock the account. However, this is something that was created by system, hence I'm not going to reset this. I'll just leave it as it is. And here we can also we have the expiry date. That means like when the password will expire. That is something we can find over here. And then we have the table space. As I mentioned earlier, like table space is one of the important concepts. We can find what table space has been assigned to a given user. And then we also have temp table space. There's a concept called temporary table space, which I don't talk about right now, but we can find out what is the temporary table space that has been assigned. And likewise, there are several other columns which are not much important, but we can always check this. All right. So similar to this, what if I want to find out what are different tables that are created? So first thing, if I do select star from sorry, select user from GL. I think I have logged in with sys user. If I do this, then I'll get lots of tables. If I select all the tables from this particular user, instead I'll change my connection. I'll change it to sales user and then select start from user underscore table, which tells us what are different tables that are created in the current user. So if I just run this command once again, you can see that I have logged in using sales user. And when I run select star from user underscore tables, it is going to give us all the metadata, all the tables information that is created underneath the sales underscore user schema, right? The same thing we can identify using select star from, let me, r underscore users, where user underscore username equal to, and we have to give it sales underscore user. And if you see here again, we have got sorry, r underscore table, and we'll have here. Now if we check this, we have created earlier a table called test with one single column, and that table is being shown here. So we can either use user underscore tables, we'll get the same table name, or we can use r underscore tables. Uh, there is something called select star from tab, and this will also give us the same information. Only difference is if we use select star from tab, this gives us the synonym details as well. So there is a type of object called synonym which is created on top of a table, and in case if there is any synonym, that can also be seen in case if we query the tab dictionary table. Now similarly, there is another table called dba underscore tables, and then we'll say that owner equal to sales underscore think, yeah, db underscore tables I'm not able to query right now because I have logged in with sales user who doesn't have the privilege to query this dictionary table. Hence let me change it to oracle connection which uses sysdba, and if I query it right now, I'll be able to see test table is also being shown. So one difference always we have to notice is like whenever we query all underscore tables, whatever the information we get, pretty much more than that we get when we do db underscore tables. Often dbs query this table, whereas the regular developers uses sales underscore all underscore tables. Ideally there should not be much difference with respect to the number of objects that we can see, but the number of columns what we get in return as a response might be different because db underscore tables often contains more information, right? So we checked how to check who are different users that are created and whether their account has expired or not. If not, then like when it is likely to expire, and whether the account is logged or not. All of this information we have seen, and then we also have seen like what are different tables that are created. In fact, like I have given owner, in the similar way I can also filter by select star from db underscore tables, where table underscore name equal to, and I'll give it as test. Let's see how many schemas have the object, have the table name as test. So here we can see that there are two schemas that are containing the same table name, that is system and sales underscore user. Both are having it, but it is not the same table. It is just this. I mean, different tables are created under different owners or different schemas. Now, as we know that there is a table called test, how do I find what are different columns that are created within this table? So for this, we can always check select star from r underscore tab underscore. So it's called calls, nothing but columns. R underscore tab underscore columns, and I can filter by tab underscore name equal to sales underscore user, and sorry, this is, and owner equal to sales underscore user. So why do I need to specify sales underscore owner? In this case, my test table exists in two different schemas. One is sales user and other one is system. I don't want to get all the columns from both the tables. Hence, I'm just filtering out to get only columns that belongs to the table test, which is created under sales underscore user schema. Now, if I run this, I can see that there is only one column that has been created. So let's check it. What are the different columns that are available in the other schema, that is sys. Let's try it. I think it is in system. And if we see here, we have two different columns. One is ID1 and the other one is call1. And if we look at the data types, ID1 has number data type and the column 1 has varchar2 data type. So we can also find several other attributes like data length, scale, nullable, and the position of the column while creating the table. All of this information can be found, and we'll talk more about this as we talk about creating the tables later on, because these plays vital role, and often we have to query these tables to find out different columns and their data types, data sizes, precision, scale, nullability, uh, attributes. So the similar way we have db underscore tab underscore calls. So start from db underscore tab underscore calls, and here also we'll apply the same filter, sales underscore user, and table underscore name equal to test. And if we run this, again we can see the same column, column 1, which is created in test table, and that is located in sales underscore user. Now we found what are different dictionary tables that can be used to retrieve the columns that are created within a table. Now how do we find out if a table has any constraints? So what we can do is select star from r underscore constraints. As we can see, this is first thing. And if I run this, and then um, I want to basically filter by table name, so I'll say table underscore name equal to test, and owner equal to sales underscore user. So this table doesn't have any constraints at this moment, right? And let me check in other schema. I think most likely I will not have anything, but let me check on other system as well, and there's nothing, right? So only when there is a constraint, then only we'll be able to find that constraint information in our underscore constraints. So what we'll do is we'll slightly change this. We'll keep it as employees, and the one is HR, which is supposed to have all the constraints. And if I run it, now we can see these are different constraint names that are created and what is the condition. In this case, anywhere we see R and all, it stands for reference constraint, C stands for check constraint, U stands for any constraint, and P stands for primary constraint, which we'll talk more about it later on. For now, so this is how we will find what are different constraints that are created on top of a table. What next? So the same way we can also query this information from DB constraints. As we can see, we got the same response. A constraint exists on a table, but how do I find what are different columns that are part of this constraint? What do I mean by that? So while creating a constraint, I can actually use two different columns, but of the same constraint to specify the conditions probably. Like usually when we want to create unique key or primary key, we can specify multiple columns. So how do I find that? Select star from r underscore con underscore columns. If you see here, and then else where actually you can actually the date constraint name and then position. If I just run this, now we can uh, each and every constraint has only one column. There is no constraint which has more than one column. In case if there is one any constraint which has more than one column, probably that constraint name would have repeated here two times, and when we look at the position it should have one two, but there is nothing which is like more than one. That means that no constraint has more than one column. Ideally we can check, I mean, in case if I want to find out what are other constraint that has more than one, where I can say that position greater than one. Let's query this, and now we can see this. So there are several such kind of objects which are created, right? And the same way we can also query it from db If you see here, just like the same way, we have the constraint name. So this is system has a constraint name, and this is the actual constraint. Sorry, this is the column name, and this is the constraint name. And then we have what at what position the column exists. In this case, as they have shown earlier, because all the concept of employees table are having only one column part of each constraint, we were not able to see multiple. However, we'll check this more in detail later point of time. So now we checked how to find different users that are created. Font, how what are different tables that are created in sales underscore user, and then we have also identified what are different columns that are created within a table, and then we have also identified what are different create constraints created on top of a table and what columns are part of what constraints. Now we'll check the same way what are different indexes that are created. So what I can do is select stars, and if I run this, we can see here there are so many indexes, right? And it has again several properties. We can talk more about it when we talk about indexes concept. For now, just imagine that like r underscore indexes is one of the dictionary table which we can really use to find out the indexes. And then the next one we have is tba indexes at another table, just like any other dictionary table, which we can use to find out all the indexes information at the table level. Now an index again can have more than one column. So what we can do is we can do r underscore in underscore columns, and if you see here, this will tell us at what position the column is present part of an index. So let's say that I have three columns which are part of the same index, then whether the column is in the first place or in the second place or in the third place, that is where to the of a query, because if the column is in the wrong place, though we have created the index on top of the column, it's not going to be useful. So the column can be anywhere in the table, but the column position with respect to the index or the constraint plays vital role. We have to keep the columns in the appropriate position. We'll talk more about it when we talk about the performance aspect of it. Now the same way we have dba underscore column, and we get the same thing again here. The next thing is like, now I found a way to figure out what are different indexes that are created on top of a table, and then what are different columns that are part of each index. Now I want to find out in case if my table is partitioned. So what I can do is select star from R, and I can specify if any table is just partitioned, where I would filter by table underscore owner, yeah, equal to products underscore data in my case. And I can actually filter by table name, just giving it for an example. And if I do this, now we can see that it has so many partitions that are created. We have approximately 101 partitions that are created table, right? And here we have like whether the partition is a composite partition or not, which means that whether it was partition multiple columns, and whether it has a subpartition or not, and what is the main partition name, and then what is the high value, because this is a list partition, I have the list value. If it is range, then and then we have the partition position, which is nothing but like, let's say that if I have 1,000 partitions on a table, then if I select another partition, I should be able to figure out exists. And always remember that different partitions can be stored in different table spaces. Hence, we can see here there's a column called table space, which tells us, so in this case, all my partitions are sitting in users table space. But as I mentioned, like we can store them in different table spaces, and we'll talk more about all these properties in the next session. And the same way, we can also do select star from partitions, and I'll get the same info, what are different partitions that are created, right? And then we have something like, what if I want to check what kind of grants the permissions have been given to a user from. And here I can. So we have something called grantor and grantee. Grantor is nothing but the person who has given the access, and grantee is nothing but the person who has received the access. So imagine that we have HR schema, and then we have sales schema, and within HR we have the employees table, and within sales we have the products table. So if HR has to access the data of products, then we have to grant the access on top of products to that will be uh, sales, and the grantee will be HR, right? So that's the information we'll be finding it here. Also have something called select star from DB underscore, and again the same information can be found also once again here. So likewise there are several other dictionary tables, lots of information that can be obtained. These are some of the tables that we frequently use day in day out part of development activity, and hope this has been helpful. In case if you have any questions, or if you want to know more about any other dictionary tables or any call not able to figure it out, feel free to comment underneath this video. I'll try to respond you, and until we meet again, take care and have a good day. Bye bye.